Welcome! This video will demonstrate setup and basic procedures for communicating with your Fusion controller using the Modbus TCP fieldbus over an Ethernet connection. Modbus TCP is a fieldbus that allows digital communication between a PLC and the controller. There are some advantages to using Modbus TCP over an analog interface. It allows access to all user parameters, it eliminates analog error, and lowers wiring installation costs. Before we begin, you'll need to install the control panel software, which is provided free with your controller. Connect power to the controller and connect to your computer with the USB cable. Now you will need to set up communication between your factory controller or PLC and the power controller. For our tutorial, we're using a laptop connected to the controller with an Ethernet cable. Let's look at a few basic procedures. First, we will identify the IP address on our controller. From the outside of the controller, you can use the up and down arrows to scroll through parameters and find the IP address. Your controller may display zeros if it is using the default factory settings. Let's also open the control panel software. On the left-hand side of the screen, you should see USB selected as the interface. Click the Connect button. Next, choose the Digital Communication tab. You will see Common Settings, and we'll come back to that later, and below that, TCP/IP settings. Here we can view or change the IP address. Now let's set our network IP address on the controller. First, we enter the address here. You will need to consult your network administrator for your correct address. For operation with industrial systems, we recommend that you only use a static IP address. This is because with DHCP, the server may reassign addresses, and the PLC will not be able to locate the correct controller. Once you have entered a static IP address, click Save. The controller display will let you know that the new IP address is being applied. It may take up to 60 seconds to change. To test the connection between our PLC and the controller, we return to the control panel and select Modbus TCP as the interface, and then hit Connect. Provided that the laptop or PLC is on the same network, the control panel will locate and display any Fusion controllers on the network. If there are more than one, you will receive a dialog box prompting you to choose one of the controllers. We are now connected to the controller and can begin viewing and adjusting our settings. Next, we will discuss reading and writing parameters. We'll specifically look at two kinds of parameters: setup parameters and monitor parameters. Setup parameters are numbered 1 through 199 and can be both read and written to. For example, digital set point, firing modes, current limits, these are all setup parameters. Parameters 200 through 389 are monitor parameters. These are read-only. They consist of process data that you may want to monitor, like load voltage or load current or load power. Okay, let's look at a very typical scenario. Say we want to write a digital set point, then read monitor parameters, like load current A, and finally process the information in order to update the set point. And then we'll repeat the process. Writing the set point is accomplished with Modbus function 6, or write single register, which requires the following information. The slave ID is 1, the parameter number is 100, and as a value we want 50%, which translates to 5,000. To read monitor parameters for load current A, we use Modbus function 3, read holding registers. Enter 1 for the slave ID, 222 for the parameter number, and for bytes put 1. We recommend consulting your PLC documentation for specific instructions on how to implement Modbus for your particular controller. And you can also find Modbus specifications online at www.modbus.org under Technical Resources. The Fusion Control Panel program also has a nice feature for finding parameters. Just hover your cursor over the value or setting you're looking for, and the corresponding parameter number will appear under the cursor. We'll briefly talk about overloading. Now, if you are reading or writing too many parameters at a time, the controller may become overloaded. To avoid overloading, use block reads to collect data more efficiently. A block read consists of up to 16 parameters. Furthermore, do not pull the controller for more than 4 block reads per second. Now let's address digital communication failure. Under the Digital Communication tab on the control panel, we see Common Settings. If communication is interrupted, whether because of a cabling issue or your PLC is shut down, this is where you specify how the controller reacts. It's a known default state that you've defined. The COM heartbeat is like a watchdog for your controller. The default factory setting is 0, which stands for an infinite timeout. When it is set to 0, if there's a communication failure, the controller will continue running as it has been, based on your last command. But maybe you want to be notified or take a specific action when you have a communication failure. Well, you have 2 options indicated by these 2 radial buttons: Continue and Stop. For our demonstration, we'll set the timeout for 5 seconds. This means the controller expects a read or write from the fieldbus at least every 5 seconds. If communication has been interrupted, it does one of 2 things. If you have the controller set to continue, it continues running at your last digital command until network communication is restored. We can demonstrate this by removing the cable. After 5 seconds, the controller displays a warning and holds the last command. So to restore communication, we correct the failure and make sure the factory controller, or the PLC, is communicating with the controller. Then the warning alarm will disappear. If you select Stop and communication is interrupted, the controller goes into an inhibit state and stops operating. You might choose this option as a safety precaution. It'll all depend on your specific application and preferences. Stop mode requires you to do 2 things to get the controller back to run state. First, restore digital communication, fix the problem, in our case restore the cable, and make sure there is communication between the factory controller, or PLC, and the controller. Then cycle Run Reset on P1 to clear the fault. These 2 steps need to happen in sequence. First, restore digital communication, and second, cycle Run Reset. An additional option would be to have the controller notify an external signaling device, like a light tower or an alarm system. You can find this option under the System tab on the control panel. Choose Communication Error here to trigger Relay 1 or Relay 2 in the event of a communication failure. For more detailed instructions, visit our website at www.ccIpower.com or contact the experts at Control Concepts Incorporated.